silver industrial applications now. Chairing this session for us is Mr. Ankur Goyal from MMTC PAMP. The president works at MMTC PAMP. Joining him on the panel for this session shall be Mr. Phillips Baker from Cristobal Mining. Also inviting on stage the head of the Advanced Materials Group at the Electrical Research and Development Association, ERDA, Dr. Nitin Shingne. And also inviting from the Silver Institute, Dr. Trevor Keel, an internationally recognized consultant, and where he focuses on promoting silver's diverse applications. And we have a video message by Mr. James Yang of Zhejiang Fudar Alloy Materials Technology Company Limited. I leave this session in the hands of Mr. Ankur Goyal.
This is an interesting session where we'll be discussing on industrial, more on the electrical contacts, new composites, and it's a very different side of the whole diaspora of silver. What we know is overall demand of silver is almost 35,000 tons, and industrial has really taken a very big stage of almost 20,000 tons of industrial silver being used in industrial application. So if you see, silver per se is, it's just not the metal right now. And it is carrying three things on its head. One is the metal, the second is currency, and now it has become a very technological important metal. And what we saw from yesterday's discussion, it's on a negative trend where demand is more than the supply. So we will also discuss to all the distinguished panelists who is here, is whether silver will become a bottleneck at the end of the day or not. So that is the thought process. Before that, we'll start with the presentation. I think you have. So we'll start with the presentation from Mr. Nitin Shingne.
Good afternoon, all. I am from Electrical Research and Development Association. We are working. I have a research group there in ERDA. And we are working on different materials for electrical industry. And one of the material is silver. Why silver? Silver is basically used in different electrical applications like contact surfaces or contact materials, high frequency applications, high power applications where high current is needed, where you coat copper bus bars with silvers, or conductive wood is used, normally used in electronics as well as some measurement devices, also sample preparation and so on. So what are the properties that silver is a precious metal and it has a high cost. You want to avoid its uses as much as possible, but in some application, it is impossible to do without silver. And why silver? Because it has one of the highest electrical conductivity. But apart from that, one major property which distinguishes silver from copper is that oxidation. When copper oxidizes, it forms a thick layer of non-conducting oxides. And this non-conducting oxide is not good for the contact surfaces. Silver forms an oxide, but its layer of this oxide layer is a conducting material, so it is not a problematic property. It forms a good contact with each other. It is more or less it have ductility, and if you alloy it with different metals, it can have a very good arcing or wear resistance. And these properties are very useful for silver uses. Contact materials can be categorized in functional contacts and moving contacts. Functional contacts are where two bus bars, for example, are meeting together, and when they meet, there is a contact resistance because they are. And contact resistance is a very important properties because there are different conductors which are joining together. There are different joints, and typically at these joints the temperature increases because of this contact resistance. You want to have it minimized, and normally at these surfaces, at these contact joints, silver is used. What I am focusing today is the braking contact which are used in the switchgear applications. So the contact material, they have to make a good, reliable electrical connections, and they should have very low contact resistance as discussed earlier, and they should have arcing, welding, and wear resistance. Of course, silver doesn't have all these properties, so we have to alloy it with different materials, that is tin, graphite, cadmium, etc. So hardness is an important property. If you want to use the switchgear is moving, it is acting a very large force on these small contacts, and heat is generated during this arcing process when current is flowing and you are suddenly breaking the contact. There is arcing, and this arcing will lead to heat and wear of the contact materials. So it should have this arc resistance as well as anti-welding, that it should not melt and stick together, otherwise your switching operation will not be possible. So what we did in our institute is alloying with, instead of tin or other metals, we added carbon nanotubes. So these carbon nanotubes have a very high aspect ratio. That means their length is very high, like 15 micrometer, but their diameter is very small, 20 to 30 nanometer. So its length to diameter ratio is high. That means its surface area is very large. If we mix these carbon nanotubes with silver, then we get a nanocomposites. And it can reinforce the silver material and adds better properties, enhance its properties. So why do we add carbon nanotube and not something else? Because carbon nanotubes has the highest mechanical properties known to us, as well as it has the highest electrical conductivity, just below the graphene. So due to these good properties, we can mix it with silver, and what we prepare is silver nanocomposites. So silver nanocomposite with these carbon nanotubes will have combination of properties which can perform better under the electrical conditions. In the laboratory, we took the silver powder and carbon nanotubes, that is black. You have to mix it, the silver and carbon nanotubes, and then you do compaction, sintering, recompaction, and then you can form the required size contact materials. These are some contact materials, tablets we formulated in our lab, and this is a microstructure analysis where how the C and Ts are dispersed in the silver powder. Compared to, for example, silver and tin oxide or silver or graphite, silver CNT has high conductivity, that is around 100 ISC standard, and it has a comparably high hardness, relatively good hardness compared to tin oxide or graphite, depending on the formulation. So major advantage is that you are not losing on the electrical conductivity compared to other alloys, and you can achieve the required hardness in this material. Second property is that contact resistance is a very important properties in these contact materials, and generally in the contact materials, when you join them in the switch gear, the temperature increases. So normally, typically, the contact resistance, the temperature for this particular 32 ampere switch gear, it should not be more than, I think, 70 degrees Celsius. So this nanocomposite contact, which was developed in ADA, and the conventional contact, both actually passes the temperature rise test. But as you can see, there is a large difference between the temperature. That means what carbon nanotube contacts actually does not increase the temperature as much as the conventional. That means the contact is very well connected with your switchgear connections, and it is not adding additional resistance, so that is good. So we have done endurance tests, long-term endurance tests. These are 6,000 operations. We put these contacts in a 32 ampere switchgear, and it was operated for 6,000 hours as per the IEC standard. And after 6,000 operations, we measured the weight. So CNT contacts actually lose very less weight compared to the conventional contacts. That means the erosion is taking place erosion is more in the conventional contact compared to the CNT contacts. And also what we prepared actually the contact with CNT needs a lesser thickness. That means we can almost save 19 weight percent of the silver material. So cost reduction is also possible. In conclusion, we can achieve balance of properties with carbon nanotube, and for example, weight reduction is also possible, and comparable conductivity is also possible, and there is a wear resistance property in the nanocomposite materials. So before ending my talk, I think there is a energy. In the electrical world, it is called energy transition. We are going through a period where our traditional sources of energy is changing towards the renewable energy, and these large shifts towards the renewable energy is leading to changes in the materials development. And silver is also playing a critical role in this sustainable future of electrical system, power system. Thank you.
Okay. Thank you, Mr. Nitin. Mr. Trevor, do you have anything to speak about, or we just go to the discussion panel?
Okay. Firstly, hi everyone. Thanks for having me along again. Thank you for organising this event. I was speaking with Mike last night, and we were reminiscing a little bit. We've been to all 4 of these events, and for us, it's so useful to be able to come to India and interact with everybody who are actively involved in the supply chain. You know, we obviously look at the silver supply chain worldwide, but it's so useful to come to specific countries and speak to people involved. So thank you once again for having us, and thanks, Mr. Ankur, for having me on this panel. So I was going to speak just briefly about industrial demand. We've obviously heard a little bit about that already, this conference. Phil gave a great presentation yesterday, which covered off some of the sort of information around photovoltaics, which was excellent. And then of course Harshal gave his introductory presentation on the World Silver Survey, which you've now all got a copy of. So hopefully you'll read that and find that very useful. I think it was another very strong year for industrial demand for silver. I think the headlines probably were that there was a slight decline in demand from the previous year, but it was still well over 600 million ounces for the year. Much of that was driven by the decline in photovoltaics that we saw last year. And it's quite interesting. I kind of thought back to this time last year, and I think we were in Udaipur around this time last year, and I couldn't remember what the price of silver was then, and so I went and had a look earlier on today. Price of silver a year ago today was $32 an ounce. And in the intervening sort of 12 months, we've seen the price of silver almost quadruple at one point. So it reached almost $120 an ounce earlier this year. And it's settled now to, I think, $75 an ounce today, roughly. So compared to this time last year, silver is 2.5 times more expensive. And that is a massive issue for any manufacturer, any industrial user of a material. And that is inevitably going to drive manufacturers to look at their costs, look at how they're using their materials. And I think that probably is a big part of why we've seen this small decline in photovoltaic demand over the last year. You know, manufacturers have to think about these issues when they are running their businesses. It's an absolute must. And frankly, looking at the use of expensive materials in any commoditized technology happens and has happened forever. I do some work for the gold industry. We've been through this process. As the gold price has risen, we've seen challenges to the use of gold in the electronics industry. And I think it was fairly inevitable that we would end up getting to a point where you see similar challenges in the photovoltaics industry with respect to silver. Now, again, we've already, and Phil's spoken a little bit about this already, but there are really two things that are happening in the market around manufacturers looking at how they use silver and trying to improve their processes. The first is very much looking at thrifting. So that is the process of taking silver and trying to use less of it. So maybe if you're printing very thin lines of silver, can you make those lines slightly thinner? Is there a way you can make them smaller and still have the same impact? So that's one thing that manufacturers are looking at. The second, and again, it's something that I think Harshal touched on yesterday, is the development of copper-based pastes, and particularly silver-coated copper pastes. So that's something that we have been aware of for a number of years now, but I think the rising price of silver has really kind of like kicked the sort of the development of those types of materials into action in recent months and probably years. So there's a lot happening within the sort of the PV sector with regards to thrifting. And the second part of the story is can silver be substituted? Can silver actually be substituted out of some of these applications? The answer at the moment is no, it can't be. Copper is the material that a lot of people are looking at, but as we've just heard, copper, there are some sort of quite significant structural challenges with copper within contact electronics, in that you get this layer of oxide effectively on top of the copper, which prevents conductivity. So this is exactly why manufacturers and paste manufacturers are looking at creating copper paste, but with a silver layer to effectively protect that copper material. Because bulk copper and bulk silver are very similar conductors. They behave similarly, but silver has this enormous advantage in these types of applications in that you don't get this conductive, non-conductive oxide layer formed. So with regards to sort of substitution, straight out substitution, we're not there yet with the photovoltaic sector, and it's very unlikely we're going to get there anytime soon. I think it's fair to say, but it's an interesting and evolving subject that I think is important to be aware of, and that this conference is a great place to discuss some of that. I was just also going to briefly mention the broader electronic space as well. There was a slight fall, again, in demand. We're still at record levels of demand for silver in the space. There was a very slight fall. Much of that sort of was a drag from the photovoltaic sector itself. But something we've seen over the last couple of years, and everybody's aware of really, is the absolute boom in demand for AI and AI applications, AI infrastructure. That's having a really supportive effect on the use of silver in the electronic space. These devices and these pieces of infrastructure are very expensive, they're very significant, they're very complicated, and they require the best materials to make sure these devices and pieces of infrastructure have longevity and operate as they should for their lifetime. And silver is a big part of that story. So I think it's going to be interesting to see what happens in the coming years. We're seeing a lot of silver go into those applications. Again, it's a similar case with gold. Gold is quite interesting. Recent years, gold demand in the electronics industry has been quite flat, even as the price of gold has absolutely shot through the roof. And the reason is there are certain applications where you cannot use anything but gold. And we're in exactly the same place with silver. There are a number of applications in the electronic space where you can't just simply say, right, I'm going to wave goodbye to silver. I'm going to use copper. It's just not feasible at this point in time. And frankly, it's unlikely to be feasible, particularly for these applications that are safety critical, that are high end, and they require longevity in their operation. So there's lots going on, I think, in the market at the moment. But silver, as we've just heard, will remain at the forefront of particularly the electronics market, I think it's fair to say. Whilst there are certain parts of the market that might be substitutable or thrifting can take place, you're always going to need significant quantities of silver in the sector. And I think that the numbers that we're seeing just go to prove that. So I just wanted to make those couple of kind of comments to start this session off. I think there are going to be questions and discussion later, so maybe we can expand on some of those sections. But thanks again for having me, and maybe pass over to Phil now.
Thank you. I think we just heard about silver used in contacts, silver in the solar industry. There are other areas where industrial application is there, like it's AI, EV batteries, sensors, and power infrastructure where silver is being used. But here, though all the three panelists have huge experience in various applications, we'll concentrate on few of the applications because definitely what is required is the clean energy right now. And silver being the best conductor, and still it is facing this a depletion phase, because what we see is though silver is used, like it's also used in the electronic components, all our circuit boards and everything. The most issue what is coming is the recovery of that being used in such a minute quantity becomes an issue. So we'll not go into the recovery side, but from the usage side, I'll ask Mr. Baker as to how does he see the potential of the solar photovoltaic, and what's the technology which is currently being used in the renewable space?
Before I answer that question, let me just make a comment that on what Trevor had mentioned. As I said yesterday, my view is industrial silver use has reached a peak in 2024. So if you go and you look at the amount of silver used industrially, 2023 was roughly 20,000 tons, 2024 was 21,000 tons, and this past year was back down to 20,000 tons. Why was it down? As Trevor said, it's from the thrifting on photovoltaics. And that thrifting is going to continue, as Trevor has said. And so you have that headwind for industrial use. When will we reach a higher level of industrial demand for silver from 2024? It's going to be a function of economic growth. It really is these applications needing more and more of the applications. So that's really the key that needs to happen. So you have that headwind, and then, specifically in the United States, and that's really my focus, from notwithstanding that I represent San Cristobal. I am a U.S. citizen. San Cristobal is a Bolivian company. And in the United States, the thing that's really evident is a war, if you will, on the use of photovoltaics and wind energy by the Trump administration. So he's involved in a lot of different wars, and this is one of them. And it's tied in large part to a battle with China being the provider of most of the photovoltaic cells. I want to say it's 80, 90+%, and it's maybe even higher than that with as they move things around the world. And so as a result of that, he in July of 2025 entered an executive order that shut down in December of last year for residential use a tax credit of 30%, and then starting July of this year, if you haven't started the project on large gigawatt sort of programs, then you're not going to get that credit. And if you haven't completed these projects by December of 2027, then you're not going to get it. That's an additional headwind. The U.S. represents about 500 tons of demand for photovoltaic, for panels that will have 500 tons worth of silver in them. And so there's another headwind that we'll have. So that puts a little bit of I'm the non-scientist here, So I'm not going to try to talk about any of the characteristics of the cells and the like.
So do you see, you mentioned that though in July 25 or earlier, there has been a reduction. So is there any incentive which has been given by the Trump administration?
Not really. There's some state incentives that you have, but not federally. And frankly, unlike other parts of the world where residential installations of solar panels have been significant. I'm on the board of an Australian company, and I was just surprised to find how much installation they have there. In fact, the cost of power during the day is negative because these solar panels are putting energy into the system, and it's quite expensive at night. We don't have anything like that in the United States, and I don't see that changing anytime soon.
Okay, so I think I have another question for both Mr. Trevor and Philip Baker. As what we just discussed was there is going to be a shift from silver to copper, and China, as I've been told, because in fact in our company we were thinking of producing silver powder for the solar paste, but then there was another thing is when you really put up a huge factory and then suddenly this Chinese coming in and changing that, the silver has moved to copper. What do you think? What is the timeline which is there currently in the near future?
I don't think you're going to get a rapid move to copper like that. None of these things move quickly because it's not as simple as just a direct material change. So you're not just removing silver one day and putting copper in the next. There's a lot more that goes into sort of that thinking from a manufacturer's perspective. It's not a drop-in solution, I think is probably the best way of explaining it. So copper, for example, and again, really you're the expert, but I can make a few sort of general comments. When you're trying to formulate copper into a photovoltaic cell, you can't do it in air. Okay, you can't, because you get this formation of the barrier effectively. So you have to do it under special conditions. That sounds like a straightforward thing to do, but it really isn't. If you've been producing silver-based photovoltaics for 15 years, it means changing an entire part of your manufacturing process. And that's not a straightforward or a cheap thing to do. So I think quite often there's this bit of a misconception around how quickly these things can move. And it really isn't just a case of swapping one material for another. And I think if you're asking a question, are we going to be seeing copper paste just dominate anytime soon? The answer is absolutely not.
Anything from you, Mr. Baker, on this? Okay. Okay, so for Mr. Nitin, I have a question as, so I think it was, and we are moving to electrical, we may be switching between the two, to electrical contacts. So how do you see, what is the barrier for this into the manufacturing setup to bring, because now we will be replacing the, like what we were discussing in the morning, and to tell you, I can share my experience. When we went into electrical contacts, we never touched cadmium. So we were only doing tin oxide contacts and all. And now what I saw was a very interesting concept of using the electrical, the nanotube, and which has a higher conductivity, which is slightly lower than graphene. So what do you see, what is the challenge which you see, or any barrier in the production, and what could be the cost, and is the industry ready for this?
Industry was not ready earlier, if I talk about like 2 years back, but now they are very much interested to trying new things. Because switchgear is a very large scale industry. Safety is their primary concern, and they suddenly don't want to change materials which may affect their product line. But now, since the price has increased tremendously, they are thinking about how to reduce this particular cost also. And one way to reduce is, of course, if you can enhance the properties and use less material, getting the same properties or better properties in the same or lesser amount. Major barrier in nanotechnology is mixing of the silver with carbon nanotubes. Carbon nanotubes has very high surface area, and as soon as you increase the surface area very high, nature doesn't like it because the free energy is high and nature wants to reduce the free energy naturally. So they have a tendency of agglomerate. These carbon nanotubes, you cannot separate it easily. You have to add large amount of energy to separate them or mix them with your silver powder. And that is the critical part of this nanotechnology, how to disperse the carbon nanotubes uniformly in the silver, and that is in a cost-efficient way. If you can do it, I think then large-scale production and large-scale uses of silver carbon nanotube is possible. This application of carbon nanotubes or graphene is using gradually, and this technology is no longer in a laboratory. It is used in our mobile phones, for example. The fast battery charging or discharging is related to adding carbon nanotubes or graphene in your battery electrodes, or they are adding graphene coating in your mobile thermal management because it has very high thermal conductivity. So these technologies are coming to our everyday use. Going towards switchgear, the industry needs to be ready, and we have to work on a solution, manufacturing solution also, to how efficiently we can mix the carbon nanotubes with silver.
So I just want to add to that, is there any reduction in the silver usage with the usage of carbon nanotubes?
Yes.
Because today also we are using silver with tin oxide or silver with cadmium or water.
Yeah.
So is with nanotubes, and how much would be that reduction?
So what I have shown is like we have obtained like 19% reduction in the silver. 19% reduction in the silver. Staying with the conductivity range, and little bit hardness is comparatively reduced compared to tin oxide. But then we have to add maybe some alloy of tin oxide as well as, or we have to increase the quantity of carbon nanotubes.
Can I just ask a question? Sure. It's really interesting, and I've seen some of this before, the approach. As you said, though, part of the challenge of this is scaling it up to the point where it's viable from a commercial perspective. So what scale have you kind of got this to? What size batches are you producing?
So we are working in a laboratory setup. So we are we have one or two mold dies. Okay. So we can produce maybe 5 or 10 these contact materials in a laboratory, and we carried out tests based on these like 15 to 20 contact materials which we have produced.
Okay, thank you.
So another point in this same contest is what I know is it's a huge gestation period. Like I would say it's a huge time period before any industry, whether it's ABB or cement, adopts an electrical contact. I've been through this journey. If we make an electrical contact, it may take almost 6 months to a year before the industry really accepts it. And then there are a lot of, I would say, I'm not going into the technical aspect, but there's a lot of structural requirement in terms of the flow of the material or the things. How are you managing it in this composite technology?
For laboratory scale, it is not a problem.
Okay.
It is a concept, and will it work it? That is what we see in the lab scale. And after its development, we approached the companies. We have earlier also approached, but there was a little bit of resistance. But from last year, I think they are actively working with us. So I think there is a possibility for this technology to going from lab scale to the industrial scale. We have to do certain modification to make it manufacturing ready. Maybe we have to carry out a lot of work with manufacturer to adopt this technology in a wide scale, I think end users are also adaptable for this.
Sure. I think you want to do it now? Okay. So just to carry on the electrical contact, this thing, we have a video, short video on electrical contacts from Mr. James. So I think we'll just go through that from James Young.
Ladies and gentlemen, I would like to extend my special thanks to Mr. Michael Direnzo and Mr. Srivatava Ganapathy. Both have invited me to join the Silver Conference in India 2026 to give a presentation regarding the silver usage in electrical contacts and also the development trends. I feel so sorry that I could not be on site due to some reasons, but I still feel so happy that I could have this chance to give a video presentation. Before my slides, I'd like to introduce myself. My name is James Yang from Zhejiang Fudar Alloys Materials Technology Company from China, acting as a Vice General Manager and also Director of International Marketing Center. So my topic today is silver in electrical contact materials and latest trends. I would like to start from the value chain of electrical contacts. Silver-based electrical contacts are widely used in low-voltage electrical apparatus, including contactors, all kinds of breakers, relays, and fuses, etc. And these electrical apparatus will finally go to various contexts, including renewable energy, electrical vehicles, data centers, industrial automation, smart building and home, etc. So we are pretty aware. And let's look at the market side. And those figures and findings are based on our own knowledge of the past years and also our own investigations to the market. And here assumption is the silver price at $1,028 per kg. And overall, it's about $6.5 billion from a global perspective, with China is dominating by $2.17 billion, followed by Europe, the Americas, Japan, Korea, and India. And so it's 4,600 tons of the silver usage in electrical contacts, and $6.5 billion we've just mentioned in 2024, with a compound annual growth rate 2%. Then we can have 5,300 tons of the silver usage by 2030, and there is actually strong correlation between the silver usage and electrical contact materials, but it's not linear. Why? Because these are decided by different factors, not only the growth of the demand, but also structural optimization and also the silver reduction activities. And we have identified three key drivers for the growth of the silver usage in electrical contacts. Here we are talking about data centers, EVs and corresponding infrastructure, and together with the renewable power generation and energy storage. Let's particularly look at these two areas for the silver usage. The first is electrical vehicles. And the methodology over here is the quantities of the EVs sales in the market. We have identified, have gained the sources from external. And in each EV, there are certain numbers of the relays. And for each relay, there are certain number of the rivets will be used. And we use average silver content for each each rivets. So then finally we multiply all these factors, we can already conclude silver usage for each electrical vehicles. And so in 2025, in conclusion, the silver usage in tonnage is between 375 tonnage until 500 more or less. With compound annual growth rate 12%, then we can already have by 2030 between 700 and 1,000 tons of the silver usage, in EVs in terms of the electrical contacts. And second, we look at the data center. So here the key methodologies were simulated from 40 megawatts data center stations, and almost the same methodologies. So there are different breakers, including ACB, MCCBs, MCBs, are used in the data centers, and then the contacts, the numbers of the contacts, and average silver contact. So all these factors together. So in 2025, we're talking about 103, gigawatts, power consumption for data centers globally. So in the end, it's about 200, more or less 250 tons of the silver usage with a compound annual growth rate 11%. Then we could have already more or less 500 tons of the silver by 2030. And we also have identified three, key directions which are more or less on the R&D stage, but also some are already in, serious productions, which have big influence to the silver usage in electrical contacts. And these are low silver and reduced silver and silver-free without compromising the electrical and mechanical performances. And this will have big influence to the silver usage. So these are all the information regarding the silver usage in electrical contacts. The following is some information about Fudar Group. So Fudar is the only company in China with fully integrated and closed loop for the supply chain from material preparation, contacts making, assemblies, and we can recycle from the production waste from electrical contact making and to silver powder and billets. Then we can close the loop. And below is the strategy of Fudar. And would like to mention three core businesses, which is Zhejiang Fudar and Zhejiang Guangda and Zhejiang Weida. For Zhejiang Fudar, specializes in silver-based contacts making. So we have consumed about 500 tons silver last year, which is of course number one in China. And for Zhejiang Guangda, so focuses on silver paste for photovoltaic and electronics applications. And also it has consumed more than 500 tons of silver last year. And for Zhejiang Weida, which is planned for the precious metals recycling and also specialty powders, which is not only for the application of electrical contacts but also for electronics. And we the capacity of our recycling is about 1,000 tons of the silver. So by 2030, all in all, the silver consumption in tonnage is projected to reach 3,000 tons within the entire Fudar Group. And we only hope we could reach that target earlier. Our mission, small material changes the big world. Thank you so much for your attention. And goodbye.
Or will copper replace, or will there be a further replacement of copper itself?
Well, I mean, look, innovation's always evolving, and you will get, like we've heard today, that the next innovation, carbon nanotubes, what comes after carbon nanotubes? Maybe it's graphene, maybe it's another 2D material. So first part of the answer is innovation's always changing. So of course there will be something. I mean, but at the end of the day, you can't change chemistry and physics. Silver will always be a better conductor than copper, and so it will always give better performance. It will last longer in many of these or most of these applications. But of course, as we've heard, the drive of trying to find replacements that will do a similar job at a cheaper price point will continue as well. So you will see copper creeping into some areas, but I maintain that particularly PV, particularly at the higher end as well, silver will continue to be the material of choice, and nothing will change that. Yeah.
Mr. Nitin?
I agree. For example, in the silver paste also, you cannot directly replace copper with silver because copper will degrade. That means it will make oxide and your paste will be useless. So you will need large innovations to replace by copper, which is not possible. And I think for high-end application like AI in data center and EVs, silver is used, and cost is not a consideration as much as performance is a major consideration there. So cost is not a problem in certain applications. So silver will be predominantly used in these new sectors also.
What I'm struck by when I think about the innovations that are happening, and they're going to continue to happen, is
Sure.
what's happened with photography.
Yeah, that's true.
So you think about the year 1999 was the peak demand for silver for photography, and it represented a third of all the demand for silver. The demand today is 700 tons.
Yes.
So it has gone nowhere, and yet industrial demand has actually increased, not dramatically, but it's increased, so it's been replaced by all these other things. And it's just the nature of the metal. It has characteristics that cannot be substituted. And so I'm very optimistic that the industrial demand will grow as economy grows and as innovation occurs.
So my last question, and it would be, which application will be the biggest driver of silver demand in the next 5 years? I would like to answer first because though I'm not have a bit of idea on the industrial side, but definitely what I've seen the current trend, silver jewelry and silver demand. Because of the increase in both gold and silver prices, there's a lot of shift of the younger generation towards silver. But from you all who have been the masters in the industrial, what do you think would be the biggest driver for silver?
The biggest growth
For silver and the industrial application in the next 5 years.
for 5 years, I think the near term, undoubtedly, the AI boom has to be the main source of the main driver for demand. I mean, again, it's something that's not going to be impacted immediately by thrifting because, as you said, that there is the cost is a different argument at this stage. These are very high-end pieces of electronic equipment where they value longevity over all, and they're not going to be risking, trying to put copper into or other metal into these devices and risk of failure. In some of these areas of use, so I think that would be my response probably in the near term at the AI boom.
Yeah, Nitin sir.
As I mentioned in my slide, energy transition is happening. That we are going from traditional sources to renewable energy, and renewable energy does not only mean solar energy, but it also wind energy. It is geothermal energy and so on. And it is also the use of EV. So the power demand is going up. It is there will be tremendous demand for electricity, and every electrical application there will be switch gears used. There will be substations, switches, transformer, reactors, and different high frequency, for example, inverters. These all applications need silver. So some amount of silver goes there. So for each application, as the energy uses go, silver use will also go up.
With renewable energy, one of the problems is it's interruptible. And with vehicles moving away from internal combustion, what they all rely upon is batteries.
Yes, the EV.
And I think that's the place where silver is in a unique position to, really change the world with battery technology.
So I think what we know is silver will be there, so we will keep having these conferences as we go along. It's AI, it's EV, and it's the power, this thing. I think anything would you like to add, or we can open it to the audience for any questions?
Maybe just one thing around. We've obviously talked about PV and the threat of substitution and thrifting. There is another part to the story as well, and that's with some of the new types of technologies coming into the photovoltaic sector. And there's, I always think, quite an interesting story. So I'll just take a minute to share it. There's an alternative technology called perovskite in the PV sector, and I started looking at this technology sort of 15, 20 years ago when it first was kind of born, really. And at the time, everyone said, right, this is going to replace traditional PV, okay? Because you're not going to need the expensive silicon, you're not going to need the expensive silver. You can take these materials, maybe put them straight onto windows because they're thin film technologies. You know, a building like this, maybe you could put these technologies straight into the windows and start generating power. In theory, a fabulous idea. You know, in theory, it would be a wonderful solution. Now, perovskite 20 years later is still around, but what they've realized is the technology itself doesn't have the longevity that you have from silver and silicon traditional technologies. So the play for perovskite has changed quite a lot. Whereas before, the idea was to sort of say, right, we're going to try and get rid of silicon and we're going to try and get rid of silver solar technologies. Now the story is very much, we can try and combine them, okay? We can try and combine them and strengthen them. And so together, the technologies, you may return a better sort of, you know, energy efficiency, but you don't have the challenge of the lack of longevity that perovskite traditionally is threatened by. And so that to me is quite interesting because all of a sudden you're saying, right, we still need silver, we still need silicon, but we can improve it with something else. And so I tell that story because I still believe maybe in 2 years, 3 years, 4 years' time, an innovation will come along that you see those types of combinations. Sure. And I don't believe that silver is just going to disappear from that. You know, you need the best materials to then step on to the next level and to provide the next level of technical kind of innovation and technical solution, which we're all looking for. You say about the energy transition. You know, the world is desperately looking for these types of technologies to help solve these challenges. And so I think the perovskite story is actually very interesting. And now there is a company in the UK that developed these tools. They are now solely looking at those tools as a tandem technology alongside silver and silicon, which I think is interesting. And so the industry will evolve, but the best materials will always be at the heart of that evolution. And I think for solar and for electronics, that's silver. So I think it's an interesting kind of way of looking at it because, as Phil said, things change, innovations come along, but you still need the sort of base innovations to build those.
Sure. Thank you. So any questions, anybody?
Okay, Dr. Nitin, excellent presentation, quite interesting also. Since we are silver contact manufacturers, at Choksera's we produce a few tons of silver graphite contacts for the MCBs and MCCBs. I was wondering, in terms of cost, normal carbon powder that we use, natural carbon, how many times more expensive is graphene powder, roughly?
Actually, carbon nanotubes, what I mentioned, they are depending on the purity. I think the cost can vary between 20,000 to 1 lakh rupees per kg.
Per kg.
Per kg. So it is cheaper than silver.
Of course.
Similar way, I think Indian companies are also producing graphene in cheaper way.
Okay.
So the cost would be lesser compared to the...
So it's sourceable here in India too?
Yeah. Yes.
Okay. All right. Thank you.
So everyone, a round of applause. Fabulous, discussion. Thank you, Dr. Trevor, Keel. You really wrapped it up very beautifully in the end. Silver, of course, is always going to be around. Amen to what Mr. Ankur Goyal said. These conferences will continue. So shall we. A big thank you